Here we improve the triangle inequality. We are given two vectors x and y. Then the theorem says that the length of x plus y is less than or equal to the length of x plus the length of y. Here's the length of x, here's the length of y, and this is vector x plus y. So we say that given a triangle, the length of one side is less than the length of the sum of the length of two other sides. We already done before. Recall that the first equality is one of the lemma we use to prove Pythagorean theorem, right? And the second one is the Cauchy-Schwarz inequality. Okay, now using these two theorems, we can prove the triangle inequality. So now we have proved the triangle inequality. So length of x plus y on square equal to this one. And now using Cauchy-Schwarz inequality, we can replace, okay, this 2 we keep the same. And the last term we can replace by 2 times is less than or equal to 2 times length of x times length of y, right? So here we use Cauchy-Schwarz inequality. And the first one we use the first lemma. And what do we have now? This means that the length of x plus, so this thing we think of it as a number, right? Because now it's just all scalar, they are all scalar. A square plus b square plus 2 times a times b, right? So this is length of x plus length of y square, right? So this is a scalar, actually a positive scalar, because this is the length of a vector, right? Big A square less than or equal to big B square, right? So you can do the square root both sides. So that means that we can do the square root both sides and give us length of x plus y less than or equal to square root of the right hand side, will give us length of x plus length of y, which is exactly the triangle inequality we need to prove. Here we're taking the square root of both sides. I want to have a comment here that the function, so okay, maybe write down. Note that we can do this because y equal to square root of x. Oh, we have too many x and y here. Okay, is an increasing function. So let me call it, say f of t equals square root of t is an increasing function, and therefore we can do the square root both sides and the inequality still stay the same, right? Sometimes we cannot do that. For example, in the case of -3 less than 1, but it doesn't mean we square both sides is the same, right? Because it's -3 less than, so this is true because this function increasing. However, for example, we cannot just go from here to there, like -3 squared 99 less than 1. This is not true, because the function x squared or f of x squared, okay, it's look like this, so it's decreasing here but increasing there. You cannot do that. Okay, here's a proof of the triangle inequality.